Good afternoon, everyone. Can you see the screen?
Yes.
Okay. The aim of the study I now present is to the use of multitemporal LiDAR data for the evaluate the carbon stock monitoring in the forest in Mediterranean area. So the study area is in Tuscany and specifically in Monte Morello, which is a forest area close to the urban city area close to Florence. And it's so the multitemporal LiDAR. So I use the overlap of two LiDAR surveys, carried out the first one in 2008 by the region in the old Ministry of Environment, which was performed in winter with the LTM Gemini sensor with 2 echoes. Flight altitude to 3,000 meters and 0.7 points per square meter. While the second LiDAR survey was carried out by Lama in 2015. In May, this flight was done after the windstorm, which made many damage in Tuscany forests. So the sensor was, in this case was a Regal LMS with full waveform, and the flight was 1,100 meters with 10 points per square meters. These data sets are collected and presented also in the paper you can see in the slide. These data are pre-processed with LastTools software to remove noise and to classify the point cloud in ground and above ground point. So as I said, we use the overlap of these two LiDAR survey, but in forest area. So we use a forest mask. In this case, we use the Greenland cover map, which for ITER is provided with the 4 level with the class that can be approximately as the forest type, as presented also a few presentations ago from Elia Vangi. And we used the field plot acquired in the local inventory with the film measure they were acquired all the 3 with dBH more than 2.5 centimeter, and also every 8 were acquired. So using the allometric equation, the volume was aggregated at plot level. So the first step for this study was to evaluate the growing stock volume in all the study area. To do so, we used the well-known area-based approach presented by NASET many years ago now. And to do so, we used the LiDAR package, the air package LiDAR. We're using that allow to evaluate several metrics. In this case, 54 airborne laser scanner metrics were evaluated that are linked to the, of course, the 8 of the point cloud, but also the distribution, such as the percentage, the percentile, and also some information about the intensity of the point, the laser pulse. These metrics are tesselled into pixels of 23 per 23 meter that mimic the dimension of the field plot that are of 30 meter of radius. Evaluation, the estimation of growing stock volume. To do so, we tried 2 models, the multiple linear regression model and random forest. For both models, we evaluate the coefficient of regression, the root mean square error, and the mean absolute error. And this on the right, you can see the study area in the forest. This is the CHN, the Canopy 8 model for the 2015 LiDAR flight. And these are the steps that we made after to evaluate, so to pass from the growing stock volume to the carbon sequestration. So we use the species-specific relationship presented in Federici et al. So from volume, using the Correlline cover typology, we evaluate the biomass. And as presented in many studies in the literature, such as this from Zhao, but also in several other, the biomass is scaled with a factor of 0.5 to evaluate the forest carbon stock. This process was executed for the flight, so for the LiDAR data from 2008 and 2015. And so we have the two forest carbon stocks, and with the difference between these two layer, we evaluate the carbon sequestration for this multitemporal analysis. So the results of the two models that we tried are these, and we tried several combination of bands. And in the table on the left, you can see the metrics that we use at the end. So are more, of course, correlated to the 8 of the pools. And in the plot on the right, you can see the result of the matrix. So the two models are quite similar. And for this reason, we decided to use the multilinear, the MLR model, because it's easier also for the implementation. And because, of course, the results are really close. So the next step was to evaluate the forest biomass, and the results for the 2008 are the biomass between 0 and 550 tons per hectares, while for the 2015 it's between 0 to 574 tons per hectare. And then we convert this biomass data to the carbon value, and the difference between the 2 years were in a carbon stored of 50,000, more than 50,000 tons, the carbon source more than 11,000 tons. As we can see on the right, with the green is the carbon stored, while the red area are the source of carbon, for a total net sink of more than 3,000 tons in this little area. It is less than 1,005 hectares. So in conclusion, looking for about also the type forest, we observe that the gain of carbon was more in conifer, while the more loss was in the broadleaf, maybe also for the more copies utilization. And this is about this our study area. But in our research, one problem is that we have not field plot close to the first field survey, so close to 2008, but just the National Forest Inventory data was 2 plots in this study area, so not enough for some evaluation of the model. But otherwise, we performed this evaluation using 2 different carbon laser scanner data that is good for this for the evaluation of volume, and with our procedure also for the carbon stock. Problem because the lack of airborne laser scanner in wall-to-wall in Italy, and also for very few multitemporal LiDAR data that don't allow a more big study of this type. And this is it. Yeah. Thank you very much.